Hello, friends! In this video, we're going to talk about the Bitwise AND operator, one of those tools that looks intimidating at first, but once it clicks, you'll start seeing it everywhere in real-world code. From checking permissions and operating systems to filtering pixels in image editors, Bitwise AND is quietly doing the heavy lifting. So let's break it down piece by piece, and by the end of this video, you'll know exactly what it does, how it works, and when professional developers actually reach for it. Let's get into it. All right, before we touch the AND part, let's quickly understand the word bitwise. When you store a number like 13 in your computer, it doesn't actually sit there as the digits 1 and 3. It's stored as a sequence of bits, zeros and ones. So 13 becomes 00001101 in binary. Now, bitwise simply means we're going to operate on each one of those bits individually, one position at a time, not the number as a whole. Every single bit gets its own treatment. Think of it like Excel applying a formula to every cell in a column instead of the whole column at once. Same idea here. Once you've got that picture in your head, the AND part becomes really easy to follow. Now, here's the rule, and it's beautifully simple. The AND operator looks at two bits, one from each number, sitting in the same position. If both of those bits are 1, the result is 1. If even one of them is a 0, the result is a 0. That's the entire rule. Look at the table. Only the last row gives us a 1 because that's the only case where both inputs are 1. It's actually the same logic you already use when you write an if statement with a logical AND, like if user is logged in and user is admin. Both conditions have to be true. The bitwise AND just applies that exact same thinking to every single bit. Now, let's see what happens when we run it on real numbers. Let me show you this in action. We've got two numbers, 12 and 10. In binary, 12 is 00001100, and 10 is 00001010. Now, we line them up vertically, just like you'd line up numbers for addition on paper. Then we apply the AND rule column by column from right to left. Position 0, 0 and 0, that's a 0. Position 1, 0 and 1, still a 0. Position 2, 1 and 0, that's a 0. And position 3, 1 and 1, finally a match, so we get a 1. Every other position has at least one 0, so the rest of the result is all zeros. Read the binary result back in decimal, and we get 8. So 12 and 10 equals 8. Notice how the AND operator basically asks which bits are switched on in both numbers, and only those survive. That's the mental model I want you to walk away with. Now let me show you a classic trick that pros actually use. Suppose you want to check if a number is even or odd. Most beginners reach for the modulo operator, number %2. But there's a faster way using bitwise AND. Just AND the number with 1. Look at the left side. We take 14 and AND it with 1. The number 1 in binary is just 0000001 with only the rightmost bit switched on. So when we AND it with any number, every position except the last one becomes 0 automatically. The result depends entirely on what that last bit was. For 14, the last bit is 0, so the answer is 0, meaning even. On the right, we do the same thing with 15. Its last bit is 1, so the result is 1, meaning odd. And here's the why behind the trick. Every odd number in binary ends in 1, and every even number ends in 0. And with 1 just isolates that final bit. This operation runs in a single CPU cycle, which is why it's used in performance-critical code like game engines and graphics drivers. Here's where bitwise AND really earns its keep. Permission systems. Every operating system, from Linux to Windows, uses this exact trick under the hood. Imagine you've got 3 permissions: read, write, and execute. Each one is assigned a power of 2. Read is 4, write is 2, execute is 1. Why powers of 2? Because in binary, each one occupies its own unique bit position, so they never overlap. Now, if a user has read and write access, you combine those by adding them. 4 plus 2 equals 6. That single number, 6, secretly carries both permissions inside it. So how do you check if the user can write? You AND their permission number with the write flag, which is 2. If the result is non-zero, the bit was on, so write access is allowed. If it's 0, access denied. This is exactly how file permissions work in Linux when you run chmod 755. It's how feature flags work in big apps. It's how Photoshop's layer blend modes are stored internally. One number, multiple yes or no answers, all checked in a single instruction. That's the real power of Bitwise AND.
Now, before we wrap up, I have to warn you about a mistake that trips up almost every beginner. There's Bitwise AND, which is a single ampersand, and there's logical AND, which is 2 ampersands. They look almost identical, but they do completely different things. Single ampersand operates on bits. It goes through every bit position and applies the AND rule, like we've been doing throughout this video. Double ampersand operates on truth values. It just asks, are both of these things true, and gives you back true or false. So 12 single ampersand 10 gives you 8, the bitwise result. But 12 double ampersand 10 gives you true, because both numbers are non-zero. Use the wrong one inside an if statement, and your code might still run, but it'll behave in ways you never intended. And these are the kinds of bugs that take hours to find. So always pause for a second and ask yourself, am I working with bits or am I working with conditions? Pick the right operator for the job.
All right, let's quickly tie it all together. Bitwise AND operates on each bit individually, not the number as a whole. The result bit is 1 only when both input bits are 1. That's the entire rule, nothing more. You'll use it to check specific bits, isolate them, or mask out the parts of a number you don't care about. And remember, single ampersand for bits, double ampersand for conditions. Mix those up and your code will misbehave in subtle ways. Once you start recognizing this operator in real code bases, you'll spot it everywhere. In graphics code, networking protocols, embedded systems, even in the Linux kernel. It's one of those small tools that quietly powers a huge chunk of the software world. If this video helped clear things up, hit that like button, subscribe to Webronaq for more programming concepts explained simply, and ring the bell so you don't miss the next one. I'll see you in the next video.